All right, guys, so here we have copper clad aluminum on this residential construction. And what we're going to be looking at here is we're going to be checking box fill. Now again, copper clad has very unique properties. So we're going to go through this one at a time. I'm going to show you this box very closely. I want you to look at this. We're going to check this. We got 1, 2, 3, 4, 5, 6 different conductors going into this one box. So let's check this out and see if we had a compliant installation. Now this particular site has copper clad aluminum. This is going to make no difference as far as calculating our box fill calculations. So let's go to the code and review what the sizes are that we have to allow. One thing to keep in mind is in the 2020 NEC and the 2021 IRC, there is one new requirement you need to be aware of. Whereas before we just took all of our equipment grinding conductors and counted it as one, which was based upon the largest conductor size. Now we take the first 4, and then after that it's a quarter per. So I hope you understand that. And we're going to move on with this box fill calculation. As we're looking in our box here, let's just look and keep in mind a few notes. We have to have a minimum of 6-inch of conductor that's brought into each box, which we have that. We have to have a minimum of 3 inches of free conductor past the face of the box, and we have that. Romex or NM sheathing is to extend a minimum of 1/4 inch into the box. I see no issue there. The plastic box is to be marked with the total volume. This box is marked. Now the box is actually upside down. When I pulled these conductors out to take a look, it was a little tricky. We ended up with 63.0 cubic inches. You're going to have to take my word for it because I couldn't get a good photograph of that. But the box is marked. There are no unbroken conductors in this case. We do not count the pigtail conductors to their devices. We add 1/4 of the largest conductor size for each equipment grinding conductor after the first 4. Keep that in mind. Support fittings, studs or hickeys count as 1, which this is a plastic box, right? One thing I do want to touch on is you count devices as 2 conductors based upon the largest wire size. Now, our largest wire size here is number 12, so that's going to be 2.0 cubic inches. So we're going to use that when we do our counting of our devices. We always get a lot of questions about, well, what else can we count, against that box fill, like the wire nuts and things like that. I'm going to give you some more details on that in a little bit, but I want to touch on the count devices as 2 conductors based upon the largest wire size. You'll hear some that'll say you count the yoke strap of the device or things like that. When we talk about a device, we're talking about a receptacle or a switch. Most of you know that. But a quick way to count devices, when I'm doing a quick calculation out in the field, I just count the number of holes, for the machine thread screws, the device. There's going to be 2 per device, right? So we see there's 1. So here's number 2. So we just continue, right? So 1, 2, 3, 4, 5, 6 holes, right? 3 devices, 3 times 2, 6. Now we got number 12 as our largest conductor size. So we're going to have 6 times their cubic inch requirement on the number 12 conductor, which is going to be 2.25. So that's how we'll come up with that number. And again, a question I get asked a lot is, you'll look at these 2 devices I have the arrows at. This is what we usually think of. They don't take up a whole lot of room. But then you look at the 2 devices here that have dimmers and such and controls that we have to the left. They take up a lot of space. So how can they be equal? Well, the short answer is one we don't like. It's because the code says so. Counting every device as exactly 2 wires might seem odd, but it's done for a few practical reasons when you look at the commentary in the code. There's a safety margin. Even small devices leave enough room in the box for wires to bend safely. And it makes the math easier. An electrician does not have to measure the exact cubic size for every specific switch or outlet on the box. And the law of averages. Again, this is from a commentary on the electric code, right? So big devices like the dimmer switches or GFCIs like you see to your left take up more room inside the box, but their large size pushes their attached wires outward. This means the total volume of the devices plus the wires roughly balances out to the standard 2-wire allowance. So to continue along this line, let's cover the things that we do not count inside the box. Wire nuts do not count in the box, and the box fill calculations. The NEC excludes them to keep the math simple while still maintaining the box safety. The main reason for this rule is that the minimum volume of the wire nuts, also called splicing connectors, take up a very small amount of space, and the safety rules that are enforced and the NEC rules. The code explicitly states that small fittings such as wire connectors and lock nuts do not need a separate volume allowance. Again, of these two things, if you're like me, you don't necessarily agree with them. There's code change, paperwork available. You can go to your IAEI group or your local inspectors group and submit a code change. Good luck with it. It takes a long time to get a code change done, but somebody has to do it. So now let's get back to our box fill calculation that we started out doing. So what we're going to have here is in this box we have a total of 6 NM cables, Romex. They're all going to be 12 gauge. There are 3 that are 12 2s, and there's 3 that are 12 3s. And of course we've already determined there will be 3 devices. So 3 things I want us to notice. Number 1, let's look at the wire nuts. Let's look at the equipment grinding conductors being tied together in the box. And let's do the box fill calculation. First thing we deal with is the wire nuts. These wire nuts are approved for the use that we have here. We have copper clad aluminum. Keep in mind, copper clad aluminum is treated the same as copper, so the wire nuts you see are perfectly acceptable for their application. We're going to do another series of videos specifically on copper clad aluminum, so be looking for those, and we'll try to cover this more. But for right now, let me just assure you that the wire nuts are acceptable for this application. Now what we do have issue with is that the equipment grinding conductors in this box are not all tied together. The code is very specific that we're trying to maintain the continuity of the grind path. So therefore all equipment grinding conductors are required to be tied together. So let's just pull out the code book, and we're in NEC Article 250-148, and this corresponds with the IRC. But specifically what I'm looking for is 250-148 on the continuity of equipment grinding conductors. And mainly I want to look at B because we're dealing with a plastic box. So let's just go straight to B. It says equipment grinding conductor continuity. The arrangement of grinding connections shall be such that the disconnection or the removal of a luminaire, receptacle, or other device fed from the box does not interrupt the electrical continuity of the equipment grinding conductors, providing an effective ground fault path. They divided these up, and it doesn't meet any of the exceptions for having done so. Number 3 on our list is box size. Now we're going to actually do the box fill calculation. Again, we're using number 12 size conductors, so we don't have to worry about mixing different size conductors. If you do, let's say you had number 12 and 14s, then you'd base your calculations upon the largest size, which is your number 12. Okay, I know we all love our math, but let's just do this. So we know we have 3 12 2s. So that's going to be a total of 6, right? And we're going to multiply that by 2.25 because 2.25 from our chart is what we use for our number 12 conductors. This is going to give us a total of 13.5 cubic inches. Then we have 3 12 3s, so that's going to be 9 of the number 12 conductors. So 9 times 2.25. Then we're going to have 6 equipment grounding conductors. For the first 4, we're going to count it once. So 1 times 2.25 is 2.25. And then we have 2 additional equipment grounding conductors. They count as a quarter per each. So that'll be 0.50. So that'll be 1.125. Now we'll talk about the devices. So we're going to have 3 devices. And so that's a total of 6, right? We counted the screw holes, remember? So we got 6 times 2.25, so that's 13.5. So our total comes to 50.625. And as crowded as this box is, it's amazing to me, the box is rated at 63.0. So we got plenty of room to play with. We probably got 13 cubic inches almost to play with. So this box will pass. So concerning this one specific box on this roughing inspection, which by the way has already passed its roughing inspection. That's very curious, isn't it? So we noticed that if we look at the 3 issues we were concerned with most on this box, we have the wire nuts are fine. The box size, box fill is good, but we had one issue, and this will be a write-up. So this should have turned the electrical inspection down anyway. Not all the equipment grounding conductors were tied together. So this would be a fail. So for this one box, we fail. The electrical inspection would fail on this house, or it should have, put it that way. Please look at our full videos. We're going to have use and application of copper clad aluminum. We're going to be talking in more detail about NM or Romex sheath cables, and also some electrical materials, the terms and basics. So be looking for all of our videos on this channel. We ask that you please subscribe and support to this channel. We need your support on this. Share, and we appreciate that, but subscribe. Look at the shorts. Well, I call them tool time shorts. This is something you just look at real quick. Usually they're about a minute, and it covers different code items. Kind of play around with some of that. Share it with your friends. I appreciate you. Thank you.